Welcome back to class. Last time we talked about particulate matter and forest fires and how those two things relate to greenhouse gases and their health effects. And this time we're going to talk about another form of air pollution. So going back to the diagram that I referred to before. So last time we talked about particulates and some other air pollutants and their effects on heart and lung disease. And this time we're going to talk about ozone. How do you make ozone? Well, to start with, ozone gets made very high in the atmosphere, and the ozone layer that shields us from ultraviolet is made by the combination of lightning electrical activity interacting with oxygen, and that energy charging the oxygen to make O2, which is oxygen that we breathe, into O3, which is ozone. So that's very helpful way up high. But down here on the Earth's surface, ozone is not so good, and it's a major problem for our lungs in particular. And ozone gets made through a different pathway at ground level. To get ozone made at ground level, you need primarily tailpipe emissions. So volatile organic compounds, VOCs, carbon monoxide, and oxides of nitrogen. And you need to get those things mixed together with ultraviolet radiation from the sun to come together, and that produces ozone. So ozone formation depends upon ultraviolet radiation from the sun, but it also depends upon temperature. And this reaction of these elements with ultraviolet goes to completion faster at higher temperatures. The reason that we have major ozone problems in the summer is because there's more ultraviolet radiation around, and less so in the winter. But even in the summer, you can see a dramatic effect, as is pictured here in two US cities, of the temperature effects upon ozone concentration. So this is Atlanta and New York. This is a picture of what's known as photochemical smog, which is largely consisting of ozone, and that's what we see as haze. And as the temperature goes up, the ozone concentration goes up because that reaction of ultraviolet with those elements goes to completion faster. What are the health effects of breathing in ozone? This is just a pyramid to say that at lower doses you have problems with lung function and inflammation. So you can see here a picture of a healthy lung, and on this side you'll see some pus and inflammation and redness. Those are all signs of ozone effects upon the lung. Up this pyramid you get to respiratory symptoms and asthma attacks, doctor visits, school absences, emergency departments, and if severe enough, ozone exposures can lead to fatal diseases. Now, ozone concentrations in the United States have been doing much better in recent decades than they have in the past, thanks to the Clean Air Act. And the Clean Air Act has dramatically reduced the precursors, the volatile organic compounds, the oxides of nitrogen, and the carbon monoxide that's needed to produce ozone. So if you don't have the precursors, regardless of how much ultraviolet there is or temperature, it's hard to make ozone. But in other parts of the world where the precursors are present and in some cases increasing, the effects of temperature contributing to worsening ozone pollution can be severe. So again, temperature has a role to play in the likelihood of ozone concentrations for many people in the world. So that's all I'm going to say about ozone, and that completes our tour of the air quality effects of climate change. Next time, we're going to look at another dimension of the ways in which climate change can affect health, and that's upon water. I'll see you then.